Here we have v of t equals integral of t sine t by 2 dt, and we have to determine the acceleration function that is denoted by a of t. So first we will have to integrate this expression, that is t sine t by 2, so that we will get the equation or the function for v of t, and then we have to differentiate the velocity function to get the acceleration function. So first, let's focus on integrating this expression, that is t sine t by 2. To integrate this with respect to t. So I'm going to use the method called integration by parts. This is integration by parts method. And in this method, we have to first choose the variable u, and we will also have to choose dv. So to choose the variable u, we will follow the rule called ILATE, that is ILATE, and each letter stands for the functions, that is I stands for inverse function, L stands for logarithmic function, A stands for algebraic function, T stands for trigonometric function, and E represents exponential function. So what we have to do here is we have to look from the left like this, and the first function that comes in this rule is I, that is inverse. And now we have to look into our expression and see if we have any inverse function. We don't have any inverse function here. So then we move on to the next function, which is the logarithmic function, and we have to look out for any logarithmic function. We don't have any logarithmic function. We then move on to the next letter A, which is algebraic function, and we have to look out for any algebraic function. Yes, we have this t. This is basically an algebraic function. So we have to choose u equals t, and once we have chosen u equal to t, the rest of the terms, including the dt, will be the dv. So I'm going to write down this u as well as dv that we have determined. So we have chosen u as t as well as dv, and this equals sine of t by 2, and we will also have to put the dt. Let's continue. So on this side, we have to take the differentials. That is, differential of u is du, and differential of t is dt. And on this side, we have to integrate. That is, we integrate both sides. Integration of dv is just v, and then integration of sine t by 2. Here we can use this formula. That is, if we have integral of sine of mx dx, this equals negative cos mx divided by m, plus we put this integration constant c. So when we use this formula, we can see that this v, so this is the formula. So we see that we can apply that formula here, and we have t in terms of x, and we can choose the m as the coefficient of x over here, and this t by 2 can be written as 1 by 2 times of t. So the coefficient of t here is 1 by 2. So therefore we can see that m equals 1 by 2. So let me apply the formula here. So therefore the integral of sine t by 2 is negative cos. This is mx, where m is 1 by 2 times of the variable is t, and then divided by m. M equals half. So I put the half here. I'm not writing this integration constant here, so we can ignore that, and we will put in the formula. So basically this expression is the v. Let's get this simplified. So this equals, we have negative here, and when you divide a quantity by half, it's equivalent to multiplying by 2. So we put negative 2 cos of this, can be written as t by 2. So this is what we have found for v. Now we have to apply the formula, that is the integration by parts formula. which says that integral u dv, and this equals uv minus integral of v du. We are going to use this formula to integrate our expression, that is t sine t by 2. So I'm going to write down this expression, that is we are given that v of t equals integral of t times of sine t by 2 dt, and we have chosen the u as t, and then the remaining terms including the dt as dv. So it is of this form, that is we can apply the formula which says that integral of u dv equals uv minus integral v du. So therefore the integral of this expression equals uv. We know that u is t, and then v is, just we have found out, it is negative 2 cos t by 2. Then we are multiplying this, and then we put minus, that is this minus, and we put integral of v du, that is v is negative 2 cos t by 2, and then du, we have already found du over here, which is dt. So we put this dt here. Now let's simplify this. So therefore this equals, we have t here and we have negative 2. So t times of negative 2 is negative 2t, and then this becomes cos of t by 2, minus, we have negative and negative, so we can put positive here, and then integral of, we have 2 here, and this 2, I'm sorry, it will not cancel. So we have 2 times of cos of t by 2 dt. In fact, we can take this 2 out of this integral. So I'm going to remove this from in the inside of the integral and put it in front of the integral. So we can put this as like this. Okay, so let's continue. So this is negative 2t cos of t by 2, and plus we have 2 times of, we have to integrate this cos of t by 2. We can utilize the formula, or let's see that we can utilize a formula similar to the one which we have already written. So if we have to integrate cos of mx, this equals sine of mx over m plus the integration constant. So when we apply this formula here, we see that m equal to half. So I can write down this, the integral of this expression is sine of m times of t. So it is sine of t by 2, and then divided by m, which is 1 by 2. We then put this integration constant c here. So let's simplify this. So this equals, we put the first expression as it is, that is negative 2t cos of t by 2, plus we have 2 here, and we have half here, 2 divided by half. So this equals 2 multiplied by the reciprocal of half, which is 2 by 1. So this equals 4. So I'm going to put 4 here, and then sine of t by 2 plus c. So basically this is the function which represents the velocity. So we write down this as velocity function as v of t. Now we will find the acceleration function. So we know that acceleration function is the derivative of the velocity function, that is v prime of t. So basically we have to find the derivative of this function v of t. So I'm going to find the derivative. So I can write down this a of t, and this equals, we have to find the derivative of this expression as well as this expression and this constant. So let's do one by one. So let's find the derivative of this expression. So here we have to apply the product rule. So when we apply the product rule, we have to consider two terms. So let's say this is the first term, and the cos of t by 2, we can consider this as a second term. So according to the product rule, we have to first find the derivative of the first function, that is derivative of negative 2t, and this equals negative 2 times of derivative of 2 is 1. So this is basically equal to negative 2. So I put this negative 2 and then multiply with the second function as it is, that is cos of t by 2. We then put plus, and now we keep the first function as it is, that is negative 2t, and multiply with the derivative of cos of t by 2. So let's find the derivative of cos of t by 2. So this equals, this is, we have to find the derivative of cos function, which is a sine function. So I put sine of t by 2, and we have to apply the chain rule to find the derivative of t by 2. The derivative of t by 2, and this equals 1 by 2 times of derivative of t is 1. So it is basically equal to 1 by 2. So this is the derivative of cos of t by 2. That is, we can put this 1 by 2 in front, which I will put here, that is 1 by 2 times of sine of t by 2. So we found the derivative of the first function. Now let's write down for the derivative of the second term. So here we have 4 times of sine of t by 2. So we can use the constant multiple rule and then put the 4 as it is, and we have to find the derivative of sine of t by 2. So derivative of sine of t by 2, we can apply the chain rule here. So first you find the derivative of sine function, which is a cos function. We put the inside function as it is, and then find the derivative of t by 2, which we have already found here, and this equals 1 by 2. So the derivative of sine of t by 2 equals 1 by 2 cos t by 2, which I'm going to replace here. So I put 1 by 2 times of cos of t by 2. We now simplify this. So we write the acceleration function, that is a of t, and this equals, we have negative 2 times of cos of t by 2. This is negative 2 cos t by 2. And then we have this negative times negative is positive. We can cancel the 2 with the 2 in the denominator. So it is positive t times of sine of t by 2. So I put t times of sine t by 2. And for the next term, we have 4 here. This can be cancelled with the 2 as 2 times. So this is 2 times of cos t by 2. 2 cos t by 2. We see that we have the like terms but with opposite signs. We have negative 2 cos t by 2 and positive 2 cos t by 2. These cancel out. And finally, we get the expression for the acceleration function, and this equals t sine t by 2. This represents the acceleration function. So answer choice D is correct.